Welcome back, Math 152 students. So our last chapter we looked at confidence intervals. That was basically saying I wanted to know something about the population, and I used sample statistics to build the population and an interval where that population parameter that we were interested in would lie. This week we're going to kind of do something different. We're going to say somebody thinks they know something about the population, and they're going to make a statement about it. And what we're going to do is take a sample and use those sample statistics to see if it's probable that that statement that someone had made is true or not true. So this whole structure, we're going to be doing hypothesis testing is basically what this is dealing with. And we're going to use hypothesis testing in for different parameters, just like we did confidence intervals, and then we'll move on. So this process is going to be very similar. The overlying test procedure is going to be very similar between different parameters that we're going to do a test on. So we're going to look at this as basically the fundamentals of building that text structure. So this is 8.1 data. So let's get started. So these are the basic principles of hypothesis testing that we're talking about. We're going to define these things in null and alternate hypothesis, state conclusions to hypothesis test, and distinguish between type 1 and type 2 errors. This information will go and then start looking at specific types of hypothesis tests based on what we need to look at. And so here's basically the structure. So let me tell you about basically the null and hypothesis test and kind of give you some background for it. So a study published in the Journal of the Air and Waste Management Association reported that the mean amount of particulate matter produced by cars and light trucks in an urban setting is 35 milligrams of particulate matter per mile of travel. Suppose that a new engine design is proposed that is intended to reduce the amount of PM in the air. There are two possible outcomes that could happen with the new engine design. Either the new design will reduce the level of particulate matter or it will not. Okay, so it could actually make it worse, right? So it could either improve or not, and that stay the same and increase. So those are two of those three possibilities. But what we're going to do is take those three of less than, equal, greater than, and group them into two types of possibilities. I want it just like I did categorical data within the category without. So we're going to build these two possibilities, take three, and turn them into two possibilities of our hypothesis. And it's going to work for all three as we build. I'll kind of add this in. This textbook doesn't give you the background with that, but I'll add that in as we go. So one of these hypotheses is called the null hypothesis. This is the one that we're going to assume is true. So if the person decides that, hey, this is true, he makes a statement, we're going to look at this, that's equalities. And then the other one is the alternate. So it's either going to improve it or it doesn't improve it. So the null hypothesis states that a parameter is equal to a specific value. It's the same as the old. It is this value. I don't think it's the old. I think it's the new value. And this is a very strong statement. So this one is the equality. The null hypothesis always assumes equality. Okay. That null hypothesis statement is H0. For the mean, for parameter mean, this would be mu0. Okay. So the alternate hypothesis is denoted by H1. Two statements, hypothesis 0, the null hypothesis, hypothesis 1, the alternate, okay? And then here's what we're going to basically do. Once we build this thing out, we're going to make a statement. We're going to make an alternate hypothesis. Then we're going to say what kind of test we're going to do, and I'm going to turn this into tail because I've spoken about tails before. Confidence intervals, we always talk about two tails, but here we're going to have the possibility of a left tail or a right tail. And we're going to let H1, when we go through this procedure, we're going to say here's H0, here's H1. H1 is going to tell us which test we're going to run. So I always want to have some mu, so if I'm going to do for the mean, I'm going to say I'm going to make a statement, and then I'm going to have one that has no equality. That's the H1. Mu is less than some mu0. This points it to the left. So we're going to do a left tail test. If the right-tailed statement is mu greater than mu 0, see it looks like an arrow to the right, that's called a right-tailed test, and we'll develop that. And then if it's a situation where we've got either mu was some value mu 0 and the alternate would be not equal to that value, it could be less than or greater than, this is this version, and we'll do a two-tailed test. The first two are one-tailed, this is the two-tailed. Okay? So boxes of a certain kind of cereal are labeled as containing 20 ounces. An inspector thinks that the mean weight may be less than this. State the appropriate null and alternate hypothesis. So I like to do, here's the claim that I want to test against. So I'm going to test that the mean weight is less. So I'm not going to do a H0, H1 yet. I'm going to start out with a claim. Mu is less than mu 0, or that 20. Mu is less than 20. Okay? And then the other one, the complement, is like I like to start out with. Here's a statement. The complement of the statement is mu is actually greater than or equal to 20, but I need just that equality is the only thing I really need out of that. But I'm really testing for against mu less than 20 or bigger than or equal to 20. But here is the number that I'm going to use as mu 0 is that 20. So here's my H1. H0 always goes with the thing with the equality. The alternate H1 is always the thing that doesn't have the equality, but this tells us the version of the test. I'm always want mu less than, greater than, not equal to a number, and that tells me it points to the left, so it's a left-tailed test that we're going to run. And we'll develop that as we go. So last year, the mean monthly rent for an apartment in a certain city was $800. A real estate agent believes that the mean rent is higher this year. State the appropriate null and alternate hypothesis. So my claim that I want to work on is that mu is actually greater than $800. The complement is mu less than or equal to $800. So that equal is the H0. So I'm going to test against the equal H0. Mu is equal to 800 against mu is greater than 800. Okay. So my mu is equal to 800 is the H0. My alternate is the H1, mu greater than 800, and that is H1, since there's no equality, that tells us a right-tailed test. Okay, so that's what we'll work on as we go through. Okay. Again, the type of test. Scores on a standardized test have a mean of 70. Some modifications are made to the test, and an educator believes that the mean may have changed. State the appropriate null and alternate hypothesis. So the educator believes that the means have changed. So he wants to test that the mu is not equal to 70. It has changed one way or the other. So it could be less than or greater than. So my first statement is mu is not equal to 70. The complement mu is equal to 70. And then I decide which one is H0 and H1. The mu is equal to 70 is my H0. That's the equality version. The not equal for mu not equal to 70 would be a two-tailed test version of that. So here's the mu is equal to 70, H0. Equality only tells me which one to be the H0. H1 is no equality there. This is a two-tailed test version from H1. Okay. So here's kind of the background of hypothesis testing. The purpose of a hypothesis test is to determine how likely it is that the null hypothesis is true. The null hypothesis is what we are assuming is true. So we're going to we're going to make this assumption that this is true. Here is our new mu for the mean. We're going to do some other ones. But for the mean, we're going to assume that that null hypothesis is true. Then we're going to go take some sample statistics from a sample and then use that to test how far away from that presumed true value. If it's too far away, we're going to know that that's statistically significant. The probability would be way off there. And then we'll either say we've confirmed that the hypothesis, the null hypothesis, is supported or not. Okay. So we're just looking for to determine how likely it is that the null hypothesis is true. So here's kind of a statement. It's kind of like behind this hypothesis test is similar to a criminal trial. At the beginning of a trial, the defendant is assumed to be innocent, or hypothesis test true. Evidence is presented from a sample. I have to go grab a sample. If the evidence strongly indicates that the defendant is guilty, we abandon the assumption of innocence and conclude that the defendant is guilty. In the hypothesis test, the null hypothesis like the defendant. At the start of the test, we assume, let's move this over here, we assume that the null hypothesis is true. We go grab some evidence by a sample and then compare that, and basically we decide whether we're going to reject the null hypothesis or accept it. Okay. So if the data strongly indicate that null hypothesis is false, we abandon that and we reject the null hypothesis. So that's from our statement. If the sample statistic is too far away from what we assume is true, then we reject the null hypothesis. So what we're going to do is we're basically going to, here's our conclusions to a hypothesis test. We're either going to reject the null hypothesis or fail to reject the null hypothesis. It's always the null. We have to go back and reconcile, is that the statement that we wanted to prove or disprove to start with? Which one is it? But we have to go through some little reconciling. But we're basically, the only thing we're going to reject or fail to reject is the null hypothesis. Okay? If the null hypothesis is rejected, the conclusion is straightforward. We conclude that the alternate hypothesis, H1, is true. We reject one, the other one we assume is true. In this case, H1. Okay? But then we have to look, well, was H1 the statement that we were trying to look at to start with, or was it the H0? The null hypothesis is not rejected. We are saying that there is not enough evidence to conclude that the alternate hypothesis is true. We are not saying the null hypothesis is true. What we are saying is that the null hypothesis might be true. We can't reject it. Okay, we either reject it or we fail to reject it. It may be true, it may not be true. So this is a weak version of it. I like to either fully reject the null hypothesis, okay, and if we reject that, then that gives us a stronger for H1. But if we don't, then that's kind of a weak version. So boxes of a certain kind of cereal are labeled as containing 20 ounces, and the inspector thinks that the mean weight may be less than this, so he performs a test of H0 mu is equal to 20. The null hypothesis versus the alternate mu less than 20. I go grab a sample, I do the thing, and I check, and basically during this check I reject the null hypothesis, state an appropriate conclusion. So basically we say, if we reject this, then there's sufficient evidence to support the mu less than 20. Okay? Because the null hypothesis, we conclude that the alternate hypothesis is true, and this is way kind of we want to conclude that we conclude that the mean weight of cereal is less than 20 ounces. We want to state the true one versus the one that we reject. Okay, so this is, we reject this, so we want to support the true one. Boxes of a certain kind of cereal labeled as containing 20 ounces. An inspector thinks that the mean weight may be less than this, so he performs a test. H0 mu is equal to 20 versus the alternate of mu less than 20. He does not reject the null hypothesis. We'll learn how to do this as we go forward, and then state an appropriate conclusion. So in this case, there was insufficient evidence to reject H0. Okay. So, because the null hypothesis is not rejected, we do not have sufficient evidence to conclude that the alternate hypothesis is true. In other words, we state there is not enough evidence to conclude that the mean weight of a cereal box is less than 20 ounces. Okay. So there's always a possibility that we can find ourselves in an error situation in here. Okay. So when we do a hypothesis test, make a decision, there's a possibility that is wrong. So let's kind of take a look at what this means. So there's two ways that we can make a wrong decision. H0 is true, but we reject it. So it was true, we went through the thing, we rejected it. This is called a type 1 error. We didn't know, we made our decision, and it was wrong. That's a type 1 error. H0 is true. This table kind of sums it up. Our decision was to reject H0, but it turned out later that we found that H0 is true. If we knew H0 was true to start with, we'd have our whole, we would know. But we don't know this to start with. We reject H0, but later we determine H0 is true. That's a type 1 error. If the decision was reject H0 and it turned out that H0 was false, that's a correct, so we're good. I failed to reject H0. H0 is true, that's a correct decision. It was true, I shouldn't reject it. My decision was failed to reject H0. H0 is false, that's a type 2 error. Okay, I failed to reject a false H0. Okay. So the dean of a business school wants to determine whether the mean starting salary of graduates of her school is greater than $50,000. She will perform a hypothesis test with the following null and alternate. Mu is equal to 50,000 versus H1 of mu greater than 50,000. Right-tail test. The true mean was $50,000 and the dean rejects H0. So she rejected it, but later on we found it was 50,000. Is this a type 1, a type 2, or correct? So it was a rejection when it was true, okay? The true mean is 50, H0 is true, but we rejected that, and that's a type 1 error, okay? So here the dean of a business school wants to determine whether the mean starting salary of graduating school is 50,000. Same thing. Here we did this test. The mu is 50,000, mu greater than 50,000. We found out the true mean was 55,000 and the dean rejects the H0. So what is this, a type 1, a type 2, or a correct? We're testing against this. We thought that it was greater than 50, then we made basically a correct decision. The dean rejected H0 when it was indeed false. The dean of a business school wants to determine whether the mean starting salary of graduate school is greater than 50,000. She performs the hypothesis test, same test, but now we find out that the true is the mean was 55,000 but did not reject. So H0 was false and we failed to reject in this case. Which type was it? The type 2 error. We didn't reject, it was false. We failed to reject when it was false. So that's a type 2. Okay? So that's the structure of the introduction to hypothesis testing, the structure of hypothesis testing. We basically have to go now, take a statement, put it into this H0, H1, determine what kind of test it is from H1, and then look at the sample statistics, the values from the sample, and see if we need to reject it or fail to reject it. And that's what's coming up into the next sections as we focus in on what are we looking at. Are we talking about the mean or the proportion as we go, or the differences later on. Okay, so I hope that helps. See you next time. Have a good day.